Here is your pre-calc final exam review. On this system of equations, I'm looking to eliminate one of the variables. It doesn't matter if I eliminate x or y. I think I'm going to choose to eliminate y if I multiply equation 2 by 2. So that gives me negative 3x plus 4y equals 9. And I multiply, I got 2x, negative 4y, and 6. Make sure you distribute the 2 across every piece of that second equation. Now, in the elimination technique of solving systems, I can add or subtract equations. If I add, I eliminate y. I end up with negative x, y is eliminated. Then divide by negative 1 or multiply by negative 1. X equals 15. Then the process is substitute in that x value and solve for y. Doesn't matter which equation you pick. I'm going to pick the second one. It looks a little bit easier to deal with. So x minus 2y equals 3. 15 minus 2y equals 3. And subtract 15. Negative 2y equals negative 12. Divide negative 2. Y equals 6. Question 2. I'm looking at an exponential equation. So that's where you start. Y equals a times b to the x. Then I'm given 2 points. So if it's a system of equations, but it's exponential, I'm going to substitute in x and y. Starting with the point 1, 8, which then gives me 8 equals a times b to the first. Then substitute the second point, and Desmos has rounded this point. So I'm going to go ahead and stick with maybe a little bit more extended version of it. So then substitute, I end up with 0.88888 equals a times b to the third. Now to combine these two, I'm going to look to use division instead of addition or subtraction. Another cool trick of systems of equations. Because if I end up dividing these two equations, it's going to eliminate a. A divided by a is 1. So take 0.88888 divided by 8, and I end up with 0.11111. And then carefully deal with the b's. So b cubed divided by b to the first, subtract my exponents, is b squared. To solve for b squared, square root. So b is approximately equal to 0.33333, which we can make exact as 1/3. So then, if I know b, I can substitute that into either equation to figure out a. So I'm going to use 8 equals a times 1/3 to the 1. I used this equation right here. Well, anything to the first power is just itself, so I end up with 8 equals 1/3 times a. To eliminate that, I can divide by 1/3 or multiply by 3 on both sides. So I end up with 24 equals a. So final answer would be y equals 24 times 1/3 to the x. Smart idea? Put this into Desmos and graph and see if the points 1, 8 and 3, 0.889 are on the graph. Next, some complex numbers. I can FOIL this or use the kind of visual technique. 3 minus 2i times 3 minus 2i. When I do that, I get 9 and negative 12i and 4i squared. I is defined as the square root of -1. So if I square both sides, I squared, the square root of -1 squared, which eliminates the square root. So I squared is -1. So then, to simplify even further, 9 minus 12i plus 4 times -1, that's -4, and -4 plus 9 is 5. So your ultimate, most simple answer is 5 minus 12i. Similar situation. I'll go ahead and FOIL this one just for fun, which looks something like this. Combine like terms, simplify your I squared. So -6 times -1 becomes +6. So -8 and +6 is -2 minus 16i. Number 5, in this one, the process is pretty cool. We're going to try to eliminate any complex piece in the denominator. So what we do is we end up multiplying by the complex conjugate. So what that is the value. Basically it's the same real value, and it's the opposite sign of the complex value. Because when I multiply those, I actually end up with a real number. I do that on the numerator and denominator. So the numerator, distribute 3, I end up with 9 plus 6i. The denominator, go ahead and multiply out. 3 minus 2i, 3 plus 2i, here's the complex conjugate piece, I get 9, -6i, 6i, which cancels those two terms, and -4i squared, which turns into 4. So this turns into 9 plus 4, which is 13. You can write it just like that, or because there's no laws of math being broken here, I'm just distributing the division. I'm not getting into the radical sign. You know who you are. I have 9/13 plus 6i over 13. That's kind of written in this a plus bi format. You'll see that a little more commonly than the top version, but both are acceptable. This is probably your most conventional answer. Division time. X plus 3 goes on the outside. X cubed plus x squared minus 16. And there's no 0 terms. Every term is represented, so you would have to have it like a 0 or 0x or a 0x squared if that was the case. But every polynomial piece going down the line is represented. I'm going to go ahead and pause and spare you the work. Process is still divide, multiply, subtract, bring down, repeat. You have to be really careful with the subtraction. Like, for example, x squared minus 3x squared. It's a negative 2x squared. And then you end up with subtracting negatives in the next line. So just be careful with your integers. Take your time. And in this case, I've got this result, this 40. It doesn't factor in evenly, so I have a remainder. So we write it like this. Plus 40 over the divisor. Now, what's cool is, okay, as we were looking at the limit, as x gets bigger and bigger and bigger and bigger, because that's, kind of what would be some end behavior, that 40 over x plus 3 becomes insignificant because it becomes 40 divided by a huge number, which is about 0. So that's kind of cool. But it is something. So we write it out. Synthetic division. Okay, there's a little trick to this piece. There is a term missing. And we look at what value of x makes a 0. So x equals 5 goes on the outside. 1x cubed, 0x squared. You need that placeholder, minus 16, and negative 45. Then we can do the process of synthetic division. Bring down the first one. multiply, and then add. Multiply, and then add. Multiply, add 0. The resultant equation is x squared plus 5x plus 9. So I really recommend using Desmos and technology because it gives you more time to solve more complicated problems. So use it. And in this case, when I graph this function, I can see one real 0 at x equals 2. The others are going to be complex. And so the process is find the resultant equation and then solve that for 0. So I'm going to use synthetic division. 2, 1, -1, 5, -14. So when I divide it out, I get x squared plus x plus 7. Those are going to represent the other two solutions, so make it equal to 0. Not factorizable, so it's quad form time, quadratic formula. A is 1, B is 1, C is 7, and x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's really horrible. So in the process of simplifying that quadratic, I end up with a negative under the square root, which is good because we want those to be complex answers because we can't see them. And so I end up with -1 plus or minus the square root of -27 over 2. Pull out the I, so I end up with -1 plus or minus I square root 27 over 2. Now if you get here, that's great. You can't divide into the radical. So you could also write, distribute the 2, but it ends up to be -1 over 2 plus or minus I square root of 27 over 2. Now there is one that's great if you get to either one of these places. There is one little simplification you could do with the square root of 27. Square root of 27, same thing as 9 times 3. Break apart the radical. You can only do that when there's multiplying or dividing going on. You could write that as 3 radical 3. So you often see this. Or maybe in college you'll see 3i radical 3 over 2. So that's just the simplification of the square root of 27 and then divided by 2, and then we put the coefficient 3 in front of the I, but I'm happy if you get to this I square root of 27. So for this last problem, I can look at it algebraically. I would probably do both. Look for it algebraically and also use technology to help you graph it. So first thing is factor out anything you can. Then look for the divide by 0 pieces, the x values, because those are bad. And then substitute those x values into the equation to look at the patterns. So first, factor. What multiplies to make -20 and adds to make -1, that'll be -5 and 4. So then the values of x, number 2, are 5 and -4. I'm going to have this canceled out x minus 5 factor, so that's going to probably indicate that that's where the removable discontinuity is, or the hole. I'm going to check that in a second. And then when I kind of simplify this, I end up with 1 over x plus 4, so -4 is most likely my vertical asymptote. I'm going to substitute those values to check. So when I substitute in x equals -4, I end up with -9 over 0, which is the indicator of a vertical asymptote. Any real number divided by 0 is usually a vertical asymptote. When I substitute in x equals 5, I ended up with 0 over 0, which tells me I've got a hole. Okay, so then I even tell you go ahead and graph it to determine the value of the limit as x approaches 4 from the left. The limit is looking at what y approaches. So I'm looking at this graph here. As x is approaching -4 from the left side, what's happening to the y? The y is going bigger in the negative, bigger in the negative. It's going to approach this asymptote, but it's becoming -infinity. Limits are what the y is approaching. Great work. Good luck on your final. Let me know if you have questions.